dihaloalkanes. Okay, so definition we can say that is dihaloalkanes. They are obtained by replacing two hydrogen atoms of an alkane with the halogen atom. Okay, so if you take, you can take some example here. Okay, that is first one is 1,1 dichloroethane. Okay, so you can observe here is one here ethane is the molecule, right? CH3 is the basic molecule. Okay, this one is the basic molecule, right? Then we are replacing hydrogen atom of this CH3 molecules with the two chlorine atoms, this chlorine and this chlorine atom. Okay, so obtained by replacing two hydrogen atoms of an alkane with the halogen atom, right? Next, if you go for second example, that is 2,2 dichloropropane. Okay, so basic molecule is a propane here, CH3 CH2 CH3, that is a basic molecule propane. Then we are replacing hydrogen atom of one of the carbon atom, right? Here we are replacing hydrogen atom of this carbon atom with the two chlorine atom, right? CH3 CH3, right? Then we are replacing two hydrogen atom with the chlorine atoms, so that will give another dihaloalkane, that is 2,2 dichloropropane. Next you go for third example, that is ethane is the basic molecule, right? Ethane is the basic molecule. We have two carbon atom, then one of the hydrogen atom of each carbon atom is replaced with chlorine atoms. Next, if we go for fourth example, the propane is the basic molecule, CH3 CH2 CH3. Then one of the hydrogen atom of the second carbon and one of the hydrogen atom of the third carbon atom is replaced with the chlorine atoms. So that will give 1,2 dichloropropane. Right, this is about dihaloalkanes. Remember that point. Dihaloalkanes, they are obtained by replacing two hydrogen atoms of an alkane with the halogen atoms. Okay, now if you observe these examples, okay, first example, second example, third example, and fourth example, we can see something, right? Yes or no? In this case, in the first example and second example, okay, chlorine atoms, we have two halogen atoms. That two halogen atoms are present on the same carbon atom. Yes or no? Here in the first position only we have two chlorine atoms. Here second example also, in the second position we have two chlorine atoms. If you go for third example, right, we have two halogen atoms, but they are present on the adjacent carbon atoms, right? Yes or no? Here, one chlorine atom present in the first carbon, another chlorine is present on the second carbon. Next, if you observe fourth example, okay, we have two halogen atoms, that's two chlorine atoms. They are present on the adjacent carbon atoms, right? One is present on the, if you number from this side, okay, here this one is a first carbon atom, this one is a second carbon atom, this is third carbon atom. First preference go for the that goes to the substituent group. Okay, first carbon and second carbon, two halogen atoms present on the adjacent carbon atoms. Now compare this first example and second example with the third and fourth one. Okay, in first two examples, two chlorine atoms, that is halogen atoms present on the same carbon atom. In the third example and fourth example, two halogen atoms are present on the adjacent carbon atom. Based on that, okay, based on that, we can classify these dihaloalkanes into two types. Okay, two types. Okay, first one is geminal dihalides. Okay, first one is geminal dihalides. Okay, second one is viginal dihalides. Okay, clear? First one, that is about geminal dihalides. Okay, dihaloalkanes containing both the halogen atoms attached to the same carbon atom, right? First two example I already observed. Okay, in that dihaloalkane that contains both the halogen atoms attached to the same carbon atom. Okay, they are called geminal dihalides. Okay, take example this one, 1,1 dichloroethane, right? So you can observe this carbon atom, right? So in this carbon atom we have two chlorine atoms, right? That two halogen atoms are attached to only one carbon atom. Okay, next if you go for second example also, that is a 2,2 dichloropropane. Okay, propane is the basic molecule, two halogen atoms, that's nothing but two chlorine atoms, they are attached to the second carbon atom, right? So clearly dihaloalkanes containing both the halogen atoms attached to the same carbon atoms. Okay, they are called geminal dihalides. Clear? Next we'll go for Next one, second type, that is a vicinal dihalides. Okay, dihaloalkanes containing two halogen atoms attached to the adjacent carbon atoms. Right, now observe this example here: 1,2 dichloroethane and 1,2 dichloropropane. Okay, in this molecule, okay, we have two carbon atoms, right? But this one is first carbon, this one is the second carbon. You can give numbering from any side, right? First carbon and second carbon. So two chlorine atoms, they are attached to the adjacent carbon atoms, right? Initially, in case of geminal halides, two halogen atoms are attached to only one carbon atom. But in case of vicinal dihalides, halogen atoms are present on the adjacent carbon atoms. Okay, so here one chlorine atom present on the first carbon, another chlorine atom present on the second carbon atom. Okay, so naming, that is 1,2 dichloroethane. Okay, if you take another example, that is 1,2 dichloropropane. Okay, so you can observe numbering from which side. You have to start numbering from right side, okay, because you have to give first preference for the substituent group. So this one is first carbon atom, this one is second carbon atom, this one is third carbon atom. Okay, so 1,2 dichloropropane, basic molecule is propane. So chlorine atoms are present on first carbon atom and second carbon atom, so they are called 1,2 dichloropropane. Clearly can observe two halogen atoms are present on the adjacent carbon atom. Okay, they are called vicinal. Clear, right? The next topic, that is a one more classification, that is a polyhaloalkanes. Okay, polyhaloalkanes. Okay, polyhaloalkanes are obtained by replacing more than two hydrogen atoms by halogen atom. Okay, so simple definition. Then we can observe example. What is CHCl3? That is a chloroform, right? CHCl3 is chloroform. What is CCl4? That is carbon tetrachloride. So you can observe here, take this one, which one? Formation of chloroform. Formation of chloroform. Initially, we have methane molecule. We have four hydrogen atoms, right? Then replace, sorry, out of four, three hydrogen atoms are replaced with the chlorine atoms, right? Here can, okay. So that type of which one? Halogen derivatives are called polyhalogen alkanes. Okay, polyhaloalkanes. Okay, or polyhalogen compounds. Okay, so in case of CCl4, basic molecule is methane, right? Basic molecule is methane. Out of four hydrogen atom of methane, all four hydrogen atoms are replaced by four chlorine atoms, right? They are replaced by chlorine atoms. Okay, next we'll go for next topic. Okay, till now we discussed about the classification of halogen compounds based on number of halogen atoms, right? Yes or no? Based on number of halogen atoms. Next basis for the classification is hybridization. Okay, class two types of halogen compounds based on hybridization. First one is compounds containing halogen atom on sp3 carbon atom. Okay, sp3 carbon atom. Second one is compounds containing halogen atom on sp2 carbon atom. Basic point, right? In case of carbon compounds, right? How to identify which one? Hybridization in case of carbon compounds. Already you discussed that in first year, right? Based on number of sigma bond. Okay, if you take sigma bond, if 4 sigma bond is there, then that compound is, if carbon contains 4 sigma bond, then that is a sp3 hybridized. If that contains a 3 sigma bond, then that is a sp2 hybridized. Okay, if that hydrocarbon, that carbon atom contains a 2 sigma bond, then that is a sp hybridized, right? You know. Next, we'll go for this one, compounds containing halogen atom on sp3 carbon atom. So, ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ, you know, right? In case of halogen compounds, okay, just take one molecule. I'll take CH3. Okay, then that carbon that will make bond with halogen, right? Halogen atom that will make bond with the carbon atom. Then you have to check the hybridization of this carbon atom. Hybridization of carbon to which halogen atom is attached. If you take a hydrocarbon, it contains more than, if you take methane, simple molecule, that is one carbon atom. Then if you take other than methane, that will contain more than one carbon atom, right? Then reference carbon atom is nothing but that carbon atom that is attached to halogen atom. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಈಗ ಒಂದು ಹೈಡ್ರೋಕಾರ್ಬನ್ ತಗೊಂಡ್ರೆ ಅಲ್ಲಿ ಮೋರ್ ದೆನ್ ಒನ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇರಬಹುದು. ಇನ್ ಕೇಸ್ ಆಫ್ ಮೋರ್ ದೆನ್ ಒನ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಯಾವ್ದನ್ನ ರೆಫರೆನ್ಸ್ ತಗೊಳ್ಬೇಕು ಫಾರ್ ದಿಸ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್? ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ದಟ್ is attached to halogen atom. Okay, yes, suppose if you take ethyl chloride, that is a CH3 CH2 Cl. Okay, we have two carbon atoms, right? First carbon, second carbon. We have two carbon atoms, in which two carbon atom, the second carbon is reference one. You have to check the hybridization of this second carbon atom, because that carbon atom is attached to this halogen atom. Clear? Yes. Next, based on that, we have three types of okay, of halogen compounds. Our first one is, that is alkyl halide. Second one is allylic halides. Third one is benzylic halides. Okay, yes. What is the basis for this classification? In this all class of organic compound, that is a halogen derivative compounds, halogen atom is attached to sp3 hybridized carbon atom. In case of alkyl halide alli halogen atom sp3 carbon ಗೆ attach ಆಗಿದೆ. allylic halide also halogen atom sp3 carbon ಗೆ attach ಆಗಿದೆ. In case of benzylic halide also the halogen atom is attached to sp3 hybridized carbon atom. sp3 hybridized carbon atom ಅಂತ ಹೇಗೆ ಗೊತ್ತಾಗುತ್ತೆ? First you have to take the reference carbon atom, then you have to count the number of sigma bond present in that particular carbon atom. Okay, so if 4 sigma bond is present, then that is a sp3. Okay, yes, we'll discuss that in detail. First we'll go for alkyl halides. Okay, first classification is alkyl halides. They are nothing but monohalogen derivatives of alkanes are called alkyl halides. Okay, monohalogen derivatives of alkanes are called alkyl halides. Nothing but we have one simple alkane molecule like methane, then one of the hydrogen atom of that alkane is replaced with the halogen atom. ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಒಂದು ಆಲ್ಕೇನ್ ಮೊಲಿಕ್ಯೂಲ್ ಇರ್ತದೆ, ಮೀಥೇನ್, ಐಥೇನ್, ಪ್ರೋಪೇನ್ ಯಾವುದಾಗಿರ್ಬೋದು. ಅದರ ಒಂದು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಅನ್ನು ಹ್ಯಾಲೋಜನ್ ಆಟಮ್ ರಿಪ್ಲೇಸ್ ಮಾಡ್ತದೆ. ಓಕೆ, ಸೊ ದೇ ಆರ್ ಕಾಲ್ಡ್ ಆಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್ಸ್. Okay, that halogen atom is attached to alkyl groups. Okay, so take example. Okay, we can go for, right, this one is methane now, right? Then one of the this one is methane now, CH4 is methane. I'll replace this one of the hydrogen atom with the chlorine atom now. Okay, chlorine atom. So this one is now methyl chloride, right? This one is now methyl chloride or chloromethane, right? Then observe the hybridization of this carbon atom. Hybridization check ಮಾಡಿ carbon idu. Is how to check hybridization? Check the hybridization of this carbon atom. In this case we have 4 sigma bonds, right? 4 sigma bonds. If carbon atom is surrounded by 4 sigma bond, then that is a sp3 hybridized. Okay, next take example of one more example, that is ethyl chloride, CH3 CH2 Cl. Okay, CH3 CH2 Cl. Okay, which one is reference one? I will give number, first carbon and second carbon. Which one is reference carbon? We have 2 carbon atom. Here carbon number 2 is reference carbon atom. You have to observe the hybridization of second carbon atom. What is the hybridization of second carbon atom? If you expand that one, what will get? CH3 C, H2 means H, then one more hydrogen atom here, CH, here Cl, right? So you can observe this carbon contains a 4 sigma bond, one here, second sigma bond, third sigma bond, fourth sigma bond. Okay, so that is carbon is sp3 hybridized. So chlorine atom is directly attached to sp3 hybridized carbon atom. Okay, so that type of halogen derivatives are called, or halogen compounds are called alkyl halides. Okay, take example, that is a methyl chloride, ethyl chloride. Okay, yes, simple example is enough. No need to expand. Suppose if they ask that for 2 marks, no need to expand that structures, just example. Okay, just write the formula. First one is, you can take example of CH3 Cl, or you can take C2H5 Cl. Okay, this one is methyl chloride, this one is ethyl chloride. Okay, so remember, in case of alkyl halides, that halogen atom is directly attached to saturated alkanes. Okay, saturated alkanes, that is saturated carbon atoms. Okay, now suppose if you take alkene, they are not called alkyl halides. Okay, in case of alkyl halides, a basic molecule is alkane, then one of the hydrogen atom of the alkane is replaced with the halogen atom. Okay, yes, next we'll go for second classification, allylic halides. Okay, allylic halides. Okay, then what are allylic groups actually? Allylic groups. Okay, here we have one example, that is, you can observe CH2 double bond CH2R. Okay, this is allylic group. Okay, general formula of allylic group artha aitalla, CH2 double bond CH2R. Okay, this one is the general formula of allylic group. Idu allylic halide alla, allylic group. Okay, now how to identify allylic group? In case of allylic group, okay, we have bonded to a carbon atom, that is in turn is bonded to doubly bonded carbon atom. Okay, now you can observe this example. This one is carbon atom, right? Okay, that is bonded to one carbon atom. That carbon atom is involved in carbon carbon double bond. Okay, so that type of carbon, okay, in which case this one, okay, if you take three carbon atom, right, we have three carbon atom here. This one is first carbon, second carbon, and third carbon. This third carbon atom is called allylic carbon. Artha aitalla, third carbon is called allylic carbon. What is the hybridization of this one? This one is sp3 hybridized, right? Because one sigma bond, two sigma bond, then from hydrogen again we have two sigma bond. It contains, this carbon atom is surrounded by four sigma bond. So this carbon atom is sp3 hybridized. Then this carbon atom is one sigma bond, two sigma bond, from hydrogen one more sigma bond, three sigma bond. So that is a sp2 hybridized. Okay, so then allylic carbon is nothing but carbon atom adjacent to carbon carbon double bond. Okay, clear? Atom. Okay, clear? Carbon atom adjacent to carbon carbon double bond are called allylic carbon atom. In this case, clearly you can observe third carbon atom is allylic because that is sp3 hybridized, that is attached to sp2 hybridized carbon atom, nothing but carbon atom attached to carbon containing carbon carbon double bond. Okay, yes, next. Okay, we'll go for definition of that. Okay, so they are nothing but monoalkanes in which the halogen atom is bonded to sp3 hybridized carbon atom next to the carbon carbon double bond. Okay, so they are called allylic halides. Okay, they are called allylic halides. Clear? Monohaloalkanes in which the halogen atom is bonded to sp3 hybridized carbon atom next to the carbon carbon double bond. Okay, so take general formula of that allylic halides. Okay, so you can observe, take it as first carbon atom, okay, second carbon atom, this one is third carbon atom, this one is halogen atom, right? Clearly you can observe third carbon is allylic carbon, right? Because that is sp3 hybridized and that is attached to sp2 hybridized carbon atom. Yes or no? Second carbon is sp2 hybridized because that contains only 3 sigma bond. Third carbon atom is sp3 hybridized because it has 4 sigma bonds. Okay, halogen atom is attached to sp3 carbon atom that is next to carbon carbon double bond. Okay, so third carbon is allylic carbon, so halogen atom is attached to allylic carbon atom. For that reason, that type of or that class of halogen derivative compounds are called allylic halides. Clear? So in this case, halogen atom is attached to sp3 carbon atom next to carbon carbon double bond. Okay, so you can take example, that is CH2 double bond CH2Cl. So in this case, this one is first carbon atom, that is sp2 hybridized, second carbon atom is sp2 hybridized, third carbon atom is sp3 hybridized, right? So this one is now allylic carbon. Yes or no? That one is allylic carbon now, right? That one is now allylic carbon. Then you can observe chlorine atom, that is halogen atom, that is directly attached to this third carbon is allylic carbon. Halogen atom is directly attached to sp3 hybridized carbon atom next to carbon-carbon double bond. Okay, so name it. Numbering from which side? You have to start numbering from which side? From left to right or right to left? In this case, we have double bond and chlorine atom. Okay, first preference for double bond or chlorine atom substituent group. So you have to give first preference for the double bond. Okay, so numbering from left side. So name is prop 1 ene, right? 3 chloro prop 1 ene, right? Name of this compound is 3 chloro prop 1 ene. Okay, ಇಲ್ಲಿ chlorine atom unto double bond unto first preference for double bond. So you have to start numbering from left to right. So chlorine atom is present on the third position. So 3 chloro, and double bond is present on the first position. So 3 chloro prop 1 ene. Okay, yes. Next, go for second example here. Okay, this one is again allyl. This is not aromatic. Clearly can observe. Okay, this is aliphatic hydrocarbon. Now we can observe double bond. One double bond is present, right? So then go for the hybridization of this carbon atoms. What is the hybridization of this carbon atom? What is the hybridization? Just number it. First carbon, second carbon, and third carbon. Okay, what is the hybridization of first carbon atom? What is the hybridization of second carbon atom? What is the hybridization of third carbon atom? First carbon atom is sp2 hybridized, right? sp2, one sigma bond, second sigma bond, one is hydrogen is present. So we have 3 sigma bonds, so that is sp2 hybridized. Second carbon also sp2 hybridized. Between first carbon and second carbon atom, we have carbon-carbon double bond. Next, go for third carbon atom. What is the hybridization of third carbon atom? 1 sigma bond, 2 sigma bond, third sigma bond from halogen atom, fourth sigma bond, one more here hydrogen atom is there. Okay, 4 sigma bonds. So third carbon atom is sp3 hybridized, right? Third carbon atom is sp3 hybridized. So sp3 hybridized carbon atom, halogen atom is attached to sp3 hybridized carbon atom. Okay, that is adjacent on the carbon-carbon double bond. Yes or no? Bromine is halogen atom. Okay, halogen atom attached to sp3 carbon atom, that is adjacent to carbon-carbon double bond. Okay, so that type of which one? So this one is this molecule is an example for allylic halides. Okay, so that's example for allylic halides. Okay, name it. What is the name of IUPAC name of that compound or that molecule? Name from which side? Right?
First carbon.
Okay, numbering from this side. This one is first carbon, this one is second carbon, third carbon. We have one substituent, one which one? Double bond. Okay, you have to give first preference for this double bond. Okay, so name it. Name ಏನಾಗುತ್ತೆ? Name ಏನಾಗುತ್ತೆ? 3 bromo, 3 bromo, cyclo, hex 1 ene. Okay, so basic molecule is cyclohexene, right? Basic molecule is cyclohexene. So in the third position we have bromine. So 3 bromo, cyclo, hex. In the first position we have double bond. So 1 ene. Okay, 3 bromo, cyclo, hex 1 ene. Okay, yes. Next, we'll go for one more classification, that is benzylic halides. Okay, benzylic halides. Okay, in this case also halogen atom is attached to sp3 hybridized carbon atom. You can observe in this benzene ring attached to CH2 group. Okay, so that which one class of molecules are called benzylic molecule. Okay, this one is benzylic group. Okay, benzene that is attached to CH2 group. Okay, CH2 group. Okay, so that is called benzylic group. You can observe. Okay, benzene ring, this carbon atom, hydrogen, hydrogen, one alkyl group. Okay, so what is the hybridization of this carbon atom now? How many sigma bonds there? If you go for hybridization of that carbon atom, what is the hybridization? That is sp3. Okay, because we have 4 sigma bonds for that carbon atom, so that is sp3 carbon atom. So suppose if that R group is X, or this hydrogen atom is replaced with the halogen atom, then they are called benzylic halides. Okay, so remember what are benzylic groups. So benzylic groups are nothing but carbon atom adjacent to benzene ring is called benzylic carbon. Okay, how to identify benzylic carbon? Carbon atom sp3 hybridized ಆಗಿರಬೇಕು, that is directly attached to benzene ring. Okay, on the sp3 hybridized carbon atom directly benzene ring ಗೆ ಅಟ್ಯಾಚ್ ಆಗಿದ್ರೆ ಆ ಕಾರ್ಬನ್ ಅನ್ನು benzylic carbon ಅಂತ ಹೇಳೋದು. Okay, yes, next if you go for definition of benzylic halides, in benzylic halides the halogen atom is bonded to sp3 hybridized carbon atom adjacent to the benzene ring. Observe this example. Okay, so we have one benzene ring, then ch2 cl. Okay, expand that one. ಏನು ಸಿಗುತ್ತೆ? Just take example that one. We have benzene, right? We have benzene ring, then this one is carbon, hydrogen, hydrogen. Okay, ch2 cl, right? So halogen atom attached to sp3 hybridized carbon, already discussed. This carbon atom is sp3 hybridized, right? This carbon atom is sp3 hybridized. Halogen atom is directly attached to sp3 carbon atom adjacent to benzene ring, right? Adjacent to benzene ring. So sp3 chlorine atom that's directly attached to sp3 hybridized carbon atom adjacent to benzene ring. Okay, they are called benzylic halides. Okay, yes, thank you.